see this is on, good. I don't know if we really need mics here in such a nice environment, very closely situated seats, so hopefully this will be a pretty intimate encounter, so to speak, and we're going to have a good panel here. I think we're the first after lunch, right? So you come in from lunch. I'm going to give folks maybe another minute or two to gather into the room before we get started, and maybe entertain you just a little bit with a story or two. I don't know. I don't have anything about blue water in the toilets. That was hard to do. Thank you. But yeah, actually, I was wondering. I'm sure all of you were, right? Why it's blue? So we've got our answer today. I have nothing to beat that with, but I think what I wanted to talk a little bit about is who am I, and then we'll do the introduction of the panel. So I'm from Red Hat. My name is Jan Fischer. I do strategic marketing for Red Hat on the products that are non-x86. So that's kind of has some other meanings outside of these walls, but here I'm here for the ARM-based servers and the ARM-based platforms. The topic today is the challenge of adopting ARM-based servers in the data centers. That's what we're going to talk about. We have a nice panel here. People you probably know and or have been interacting with in the past, if not directly but indirectly. We'll do the intros in a second. But before we get started, I guess one of the things that I wanted to ask you, if any of you could take the wildest guess possible as to what these numbers could mean. And if you do, just raise your hand and give me some ideas. So the numbers are 90 to 1 and 10 to 4. Yes, you know the answer. Oh, yeah. Well, it's missing another 254 digits, but yes. All right, any ideas? Any ideas from the audience? First of all, are you awake? Are you still with me? Lunch was good, I heard. Yeah, I tried some. Yeah, it was good. Tasty. They feed you well here, so that's a big plus. I think Linaro was here, just walked in, so we better say only good things about Linaro and then them sponsoring this event. So yeah, what really do these numbers mean? Any ideas? How would these numbers be applicable to ARM data center ecosystem or ARM servers in general? Any thoughts whatsoever? All right, so I don't see any hands. I'm going to do a little bit of a reveal here. So we have, according to our lovely friends at ITC, 90% of the entire server market. This is not new shipments. This is total share by revenue belonging to one architecture out there, and that's x86. It's not just Intel, granted, right? There's also AMD, whom we've heard earlier today. Everyone loves to keep as a second option, but not really. And then there is, and then there is other architectures, which are the list actually is longer than 4. I think there's some very boutique architectures that I never heard of, but they combined, they compose of account for 10% of the total market share, right? So here lies our challenge. One of these architectures, one out of 4 is ARM, right? And so this is the uphill battle that all of us are facing in our different capacities and roles, whether it's technical, business development, marketing, engineering, et cetera, right? We are going against massive 800, 900 pound gorilla, as the Americans say. I don't know if it has any meanings in other languages, but that's how we like to describe that, right? What can we do together as a community, as an ecosystem, to try to address and help the the upcoming architecture, right? So today, I'm very pleased, I'm actually thrilled to announce our panel. We have from here Larry, who is from Cavium and also from other places before. So I think Larry has probably been at it in terms of the ARM server ecosystem the longest. That's one of the reasons why I felt he would be a good representative for the overall community, to kind of talk about challenges in implementing ARM architecture in silicon and also driving it to market, bringing it to market. We have John Masters, who doesn't need any introduction, so I'll skip right over that. And we obviously have Lindert, who we heard this morning, and very engaging keynote. Thank you very much for that. It was great to know and hear what you guys are doing at Microsoft. And again, I think we are all looking at you, not just Microsoft in the traditional sense as an OS provider, but more of a cloud provider, driving Azure adoption there. And we definitely would like to hear more, right? And I'm going to be your humble moderator. So if you have any questions, the panelists, we're going to go and discuss a couple of topics, and then we'll leave enough time, hopefully, for questions and answers at the end, right? So I think one of the things that we want to establish early on, right, is the fact that we have shipped, or every major OS vendor, let me put it this way, has shipped the version of the operating system that can be used on ARM servers. Whether we're supporting them today fully, or there's some constraints, this is really not that important. The fact that everyone has a version of the OS that could work on the servers is very important. So the real question is, do we have enough hardware, do we have enough servers out there to make that happen? And I think we are getting to that point. There is, this year is certainly going to give us some interesting stats in terms of what we have in the data centers. Sorry, I think I didn't need that one anymore. Yeah, so we will see how the adoption curve is going, but as we're planning on that, we also probably want to know what our actual trajectory is going to be, and maybe predicting that trajectory with the help of our panel would be the goal of this discussion, right? So I would like to turn to Larry first and ask you, from the perspective of silicon vendor, having been also in the industry for, and in that specific portion of the industry for a while, how would you describe the workloads, and how would you describe the focus area for your designs? What are you trying to achieve there? What are the market segments that you're going after that either you think would make ARM servers successful against x86, or maybe complementary to x86? That's I think that's a good question.
Well, that's a good question you asked me. So I'll touch on a couple of segments that we've focused on today. And primarily that's been cloud and HPC. You heard Leonard talk about cloud this morning from the Microsoft Azure perspective. I think he did a good job of setting that tone and some of the requirements in that space. So I'll touch on HPC a little bit more here. HPC is an interesting industry in that it is very much technically driven from the standpoint of benchmarks, and there's a core competitive capability that you just have to have. So from Cavium's perspective, we're on our second generation ARM server, Thunder X2, and we're at a point now where we have end users and partners publicly talking about benchmarks that are relevant to that space, which has been something we've kind of struggled with in the ARM space for quite a while in terms of we haven't been to that point. So there's a validation from a core compute standpoint, from a scalability standpoint, and particularly in HPC, memory bandwidth and memory capacity is significant for a number of applications, and we've been able to demonstrate that. So even within HPC, we've kind of targeted some of the specific differentiators we have. Now, where we've had early success is certainly in U.S. Department of Energy labs, in research areas. One of the emerging areas is commercial with EDA. So we had an announcement last October. Cavium, ARM, and Qualcomm all partnered with Cadence for commercial EDA application space. So now we're moving into that ISV space that's really critical as you get into more the commercial side of HPC. The other piece I'll add is that to be successful there, generally in the server space, certainly in HPC, is the OEM partner. We've worked with both HPE and Cray in the US, Bull in Europe. Those OEMs have really key partnerships with the end users, and that adds a level of credibility of what it takes to deliver and support those customers, but also ultimately execute on all the features and capabilities that they're looking for.
Thank you. Yeah, so I think one of the, you covered HPC very well, but one of the other aspects of, of target markets for the ARM is obviously cloud providers and the whole cloud implementations as well. So I mean, we're very lucky to have Lindert in the room, so maybe you can add a couple of words there. I mean, we saw the footprint, the approach that Microsoft takes in implementing the data centers, but as you considering or evaluating ARM to be part of those data centers, were there any specific, or are there any specific issues and things that you find, saying inconsistencies that we should be aware of? What are the challenges, so to speak?
So yeah, so let me address a couple of them. So this is all about adoption of ARM, right? So clearly I want to state, first of all, we're evaluating ARM. We're not at a stage yet where we're committed to go and deploy it. But part of that is to figure out what is that end-to-end story. And there's a lot of components to it, right? One is actually building the motherboard and getting software up and running. And there's some challenges there, and I can talk about that. But then there is also, once you've got a server, you put it in a chassis. You're going to run validations tests on that, and burn-in tests, right? Stuff like that. Things that are missing, right? Have you ever thought about, and it turned out that this is quite hard, running a machine at 100% of its power utilization for 24 hours, right? That's like a burn-in test. On x86, these tools exist. In the ARM ecosystem, it's actually quite difficult to get an ARM server to 100% utilization. And that's just one example. So there's a lot of these test and validation suites that we have, but that our ODMs and our partners have as well, that all exist for the x86 ecosystem, don't exist for ARM at all. The other thing is, as we're starting to run real applications on it, we're seeing performance issues, right? We're doing ARM, yes, we've got a strategic objective around it, but there needs to be a value proposition for us as well, right? We're not going to run at 50% of the performance level of a comparable x86 processor. That doesn't make any sense for us. So while the hardware is sort of getting, at least from a spec int and spec rate perspective, to the right levels of performance, we're then finding that there is a lot of software optimizations missing, right? On the Intel side, on the x86 side, there's been 30, almost 40 years of performance optimizations. We haven't got any of that really on the ARM side. So we're finding a lot of cases, and it's sort of a whack-a-mole kind of game, right? Something pops up here, you go whack it down, and something pops up there. But things like, in our storage stack, we use a lot of CRC checksums. Guess what? There is a fast path for CRC on x86. It doesn't exist for ARM. So once you start first running those benchmarks and those workloads, ARM platforms really suck in comparison. So those are things. And then there are some hardware issues, like everybody is implementing at this point ARM. Well, I'm going to ignore all the non-standard kind of stuff. I just don't want to deal with that kind of shit. Basically, you fix that. But the other stuff that I deal with is, like, a lot of these processors implement the ARM 8.0, 8.1 instruction set. It turns out that there are some very serious design deficiencies there. To give you an example, I have an object store, a Bing object store program that spends 80% of its time in two operations, two interlocked operations, two atomic operations. And that's because the way to implement it on ARM and that instruction set, and that version of the instruction set, is to compare and exchange, to atomic compare and exchange. Right? So the net result of it means that 20 ARM threads is comparable to 10 Broadwell threads, which is that 50% magic number that I just mentioned, right? So that's not good. Now, fortunately, this is something that ARM is changing in later versions, but that also then means is I need to get the next version of the processor because the current version doesn't implement that. So we're sort of getting at the stage where we can start running real applications, and we're now sort of finding things like, hey, this doesn't work too well, or that doesn't work too well. And yet you can say, well, Microsoft, rewrite your application so that you don't depend on that atomic operation there. But then the question is why, right? It works on all these other platforms. So it's really that kind of interesting findings that we're getting to at this point, where we need to do a lot more of.
Well, so you touched on a couple of things, and I think what I kind of, if I may summarize, one of the things is the any advantage that R may have because of no, or ARM architecture has, because of no dependencies on the previous code or existing code, could be negated because of this very same reason, because there is no implementation of certain things, right? That's really kind of balances out the advantages that you may have in terms of the optimization of the code and execution pipeline, right?
Exactly, right? So the ARM cores themselves definitely have an inherent advantage over x86, right? They're simpler, they're smaller, therefore you can do more of them. There are definitely, if you take an x86 processor and exactly the same technology and you build a similar kind of ARM processor, you can probably be 10 to 15% faster, but you're also wasting a lot of that stuff on not having the right software optimizations in place. So, yes.
Right, and so the software is the key there, because that's how we interface with all of our processors and systems, and I'm sure it's fair to say that there's a lot of heavy lifting involved in that. And maybe John, I mean, you're known for being the huge advocate of making ARM boring. That really means running the software as you should out of the box without any modifications. What can you tell us about, you know, now that the Red Hat and everybody else, even Oracle, has the operating system out that supports ARM, and that's all goodness for the community, of course, and you know the common work that we do. Is there anything that you think we, as collectively as the ecosystem participants, can do to expedite or enhance the delivery of various software pieces in the stack directly to the ecosystem and, you know, to the upstream, as well as then further into the distributions? What Red Hat can do, maybe, since you still work there, last I checked?
Apparently I'm still employed by the company today.
Right, yeah. Well, some days it feels like you work for ARM, but that's okay. Or
they just need to give me a badge. It's fine. So Linda was saying, I've got the Microsoft tablet here. You know, actually very happy with what they've done to accelerate the ecosystem. And we did a good keynote this morning, and I think Microsoft is actually one of the biggest friends that we all have here, because, and I'll take a slight tangent here. This is where I say, I've been pushing for years for ARM servers to be boring, but I think to an extent, Linda mentioned the sort of the hyping. I'm one of the guilty parties that has hyped ARM servers a lot over the years. And so what I'm very keen that we do going forward is we're very realistic about expectations. We've achieved a huge amount over the past 7, 8 years. What we need to do now is be very realistic and very focused going into these engagements. It is a bit of a whack-a-mole. We've got a lot of things popping up where, you know, I was talking this week about DPDK and network performance and different things where we can solve one problem, we solve another. If we are focused in what we're trying to achieve, we have a good chance to get some really serious adoption. We have a lot of challenges, but we've achieved a huge amount. We have made things fairly boring. Still a lot more work to do to make it, there's still more work to do to make it what I would consider truly boring, to Linda's point, right? Now, what can we do together? So this is where he wants me to give a plug for something that we're working on, but I'll talk more broadly. We've been talking a lot recently about operating system vendors like Red Hat who want to, you know, put the investment into porting the OS, right? And that's a lot of investment dollars. I mean, I like Linda had a comment in a second too about Microsoft, but it's a non-trivial amount of money to port an operating system. And it's even more money to take that to market. And there's even more money and more investment to build products on top of that. So I think one of the challenges and frustrations that people have had, quite fairly, from a community point of view, and they've directed at me, is say, well, it's great that you're building RHEL, and that there's CentOS available now and so on, but what about all the other stuff that we want to run? and it's a never-ending list of things, right? So how can we achieve that together? And I think we can be a bit smarter going forward, now that we have a lot of enablement work going into the upstream community. So Marcin's sitting here, I'm just picking on him because he's involved in the OpenStack work that Linaro is doing. That's one example where Linaro and the vendors have gotten together and done some really good enablement work. So how do we take that upstream and deliver it to customers and to users in a way that they can consume it and they can make the business case for vendors like myself, my company, taking that technology to market as well. And I think what we should do over the next year is work together in both the upstream communities and then also the downstream communities. In the Red Hat case, and it's similar for other companies, we have sort of downstream community projects like RDO, which used to stand for Red Hat Distribution of OpenStack, and now just is a collection of OpenStack communities or something like this, right? So that would be an example where those who are interested in running OpenStack in environments based on RHEL, CentOS, Oracle, any of these compatible distros could work together in the RDO community to enable that. That's just one example. So I think there's a lot of work we can do together to be a bit smarter about our investments, getting the upstreams enabled, but then also working downstream to help build the technologies together.
Yeah, thank you. So I think the summary of that is that if we don't collaborate, it will take years and years of individual vendors doing their own thing on their own accord. So it is the consolidation of effort that we're all looking for here. And with that, I think we only have, this was a very short panel, so we only have a few minutes for questions. I'd really like you guys to be actively participating. So any questions for our distinguished panel here? Okay, well, let's start here. My mic.
Yeah, thank you. So, are there any plans at Microsoft to have or to support Windows VMs or cloud images on ARM?
So those are two questions, right? So you're asking about a retail version of Windows, and the answer is no, because we don't see a business for that. Well, other than on the client side. Obviously, the client side is a different story. Public cloud services based on ARM, that all depends on customer demand, right? If we have sufficient number of customers asking for it, we may consider putting that up. We definitely have the infrastructure for it, but we will have the infrastructure for it. But it all is a matter of, are there people asking for it, and are we actually, can we make money off it?
Okay, Scott, okay.
So, Leander, you mentioned that from a spec-in perspective, we have hardware that looks performant or competitive with other architectures.
You need to be careful. There's spec it and spec rate.
Right.
From a spec rate perspective, we're definitely seeing interesting numbers. I think from a spec int perspective, so the per thread performance not quite there yet.
So, so from a socket perspective, for spec int rate, we have competitive hardware solutions compared to what's deployed today. Everybody's also mentioned that there's maybe a suboptimal software ecosystem right now. We have some performance holes in possibly compilers or application development or libraries. Are there other performance proxies, mini apps, or benchmarks that we would want to see performance on to show performance potential, even though our software ecosystem may not be in as good a shape as x86, for instance?
So the final answer is obviously yes, and those are the actual applications I want to run, right? But I think in order to get there, there's another aspect of it as well. You need to be really focused and say, okay, what kind of applications do I want to go after? So in Azure, I'm not going after all those applications that are on the list. I don't have the resources for it. It doesn't make sense to go and invest in all of them, right? But I am investing in a few of them and getting them over the finish line. And so it's very focused. And I'm not going to say here which ones they are, but it's very focused, and I do exactly what I need to do to offer those applications to be performant. Because in the end, the best thing I can do as Microsoft is actually have a real deployment of this, right? That's going to matter much more if I can stand up and say, hey, I'm deploying ARM server in the cloud and it's being competitive with the workloads I run on it, than trying to enable everything, because then I won't get there.
So I think we have time for just one more question. I'm watching the room, so just raise your hand if you have a question. I'll be happy to give you the mic. Okay, let's do that.
So you talked about how, I guess, the traditional enterprise space is probably not something where ARM is going to succeed, at least easily. There's the cloud, which y'all are working on. I mean, do you see an opportunity for ARM server class systems, SBSA type systems on the edge, like edge compute, fog computing, where it's it's not exactly enterprise. There's like Azure Edge IoT type systems that might be near the edge. Is that a place where ARM has an opportunity to maybe gain market share with the ARM servers?
So there definitely is, but it all depends, it all comes down to what applications are you running on it, right? It's about the software. I mean, the hardware is sort of irrelevant here. So if you run customer applications there that the customer develops, that's by definition going to be x86, because that's the ecosystem that exists out there. Right? If these are internal apps, then yes, these could easily be ARM platforms.
Excellent. So I would add that I agree with that statement. I do think there's a huge opportunity in the edge and fog for ARM server systems, and I agree that traditional customer app deployment, that's a challenge. But if you look at the transition we're about to undergo to 5G networks and deploying EPC-based solutions very close to the edge, I think there's a big opportunity to intersect that and have some significant deployment, because you're going to have very large numbers of systems out there where you're in power constrained environments, you've got lots of local environmental constraints, and I think that a lot of the ARM vendors have some very interesting offerings there. Harry, do you want to add anything to that?
Yeah, one thing I'll add is just architecturally with ARM and SoCs, there's a lot you can do for accelerators and integration at the hardware level that really plays well into that space. I think you're going to see that more and more from the ARM side.
Great, thank you. On that, I think we're just simply out of time. This is a good discussion. We can continue in the hallway, but we're going to yield to the next set of presenters. I'd like to hear a nice, strong round of applause to our panel. Thank you guys for being here, and thank you for stopping by.